Hello friends, welcome to Joy of Life. So today we are going to look at another medium level problem from Leetcode. The problem number is 560. And the name of the problem is Subarray sum equals k. So given an array of integer nums and an integer k, return the total number of continuous subarrays whose sum is equal to k. So here we see some example that we have a 1, 1, 1 and our target is 2, k is 2. So if you see that if we add these two 1, we can get a 2. If we add these two 1 also, you can get a 2. So there are two ways we can get a 2 from this array, right? So the answer is 2. So again, another example, we have 1, 2, 3 in the array and the k is 3. And if you see that if we do a 1 plus 2, we get a 3 and the 3 itself can make a 3, right? So the output is 2 over here. So we need to find out how many such continuous subarrays that we can make. So the important part over here is the continuous subarray. So it has to be continuous. It should not be broken. So if you see that the lines that I have drawn, they are continuous, right? It's not broken. It's not like this, right? It's continuous. It should be one straight line, right? So this is the problem all about. As I always recommend, to give it a try to see if you can solve the trick behind the problem. You can use a pen and a paper in order to come up with the solution. And once you have the solution, the code is very simple. For any problem, it applies that once you have the solution, it's going to be pretty simple. So do give it a try before you look at the solution over here. So let's head over to the board and check out the solution. So what I have done is I have taken an array over here and we are going to see how we are going to use this array in order to come up with the required result, right? So let's say we have an array over here of size 10 and our k is 6. So we are looking for a 6 over here. So if you see this array, there are multiple occurrences of 6 over here. So let's put some lines around it and see. So we have a 6 over here. We have a 6 over here. We have a 6 over here as well. We have a 6 over here. We have a 6 over here. This single 6 can also make a 6. So we have a 6 over here as well, and the total occurrences what I see is 6. So there are 6 occurrences where we have this subarray whose sum is 6. So let's understand the trick behind the same and let's see how we can come up with the solution. So I've made a copy of the array and let's understand the simplicity of this problem. So what we are going to do is we are going to maintain a running sum. So what does a running sum mean? At every step what we are going to do is we are going to add up. So our sum starts from say 0. So every step we are doing a sum. So 0 plus 1 over here we have a sum 1. 5 plus 1 we have a sum 6. 6 plus 3 we have a sum 9 and so on. So now just let's look at this and understand that how we can find out the solution from this running sum, right? So let's take one example where we have seen a 6, right? So here is one place where we have seen a 6. So using this 4 and 2, right? So when we reach this 2, our sum is basically 15, right? And if we maintain my previous sums that I have seen previously, so I could easily say that I have seen 1 one time, 6 one time, 9 one time, and 13 one time, standing at this value 2. So what I can say is that I have a sum of 15. I have a requirement of 6. 15 minus 6 is a 9, right? So I will ask my map, did I saw a 9 somewhere? And it will tell me, yes, you have seen a 9. And the 9 is over here, right? So I know that this gap from 9 to this 15 is going to be a gap of 6, right? And that is where my answer lies. So again, if you see that if I move on right over here, the result that I found over here is a 15, right? And I ask my map that have you seen a 9? So it says, yeah, I have seen a 9 over here. So again, from here, from this value to this 9 is again a value which is 6, right? And we are going to maintain a count, right? Wherein we are going to increment the count as and when we get this matches. At the last two index also, you can see that we have a 3 plus 3, 6 over here, right? So how will this be converted? So what will happen is when I am at the value 32, so what I have to do to get a 6, right? I have to reduce a 6 from this. So if I reduce a 6 from this, what I get is a 26, right? At this point, I will have all these value inside my map, right? So I have added till 13. So let me put the other thing. So 15 is something that we have seen twice, right? And 21 we have seen once. 26 we have seen once, and 29 we have seen once. So now I'm going to ask my map, did you saw a 26? And he says, yeah, I have seen a 26. So I know that 26 is over here, and the gap between these two values is going to be a 6, right? It has to be. It's just a subtraction principle that we are using, right? So this is the trick behind the same, that we are going to have a map and we are going to store whatever we have seen so far, and we are going to capitalize on that continuously. Do a dry run wherein we take some negative values and see how it goes. So I've taken an array over here and we're going to do a dry run, which will cover some of the edge cases that we have not discussed, because our previous example consisted of only positive numbers. But here I have mixed the positive and the negative numbers, and for a 5, our k is set to 5. The array is of size 8, so we have index starting from 0 to 7. These are nothing but the index, and we have taken the values from the map, and I have maintained the running sum for your reference over here, though we are going to uh, put it here when we do the dry run, as and when we get it. So we have the required over here. So required is nothing but sum minus k, the required value, the value that can take the sum to k, that value that we'll be checking. And also we are maintaining a count. So this count is going to tell us that how many times we have seen this subarray whose sum is equals to k. So there are two ways of incrementing count. So one is a direct increment. When I see my sum is equals to k, I can directly do a count plus plus, or I can do a count equals to count plus scene dot get of required. So whatever required value is there, we are going to take that required value and check into this scene map over here. So this map has a sum as the key and count a number of occurrences of that sum as the value, and we are going to check that map, and you will soon see how it all falls into place, right? To start with, index 0, we have a value of 8, so we are going to put the sum at 8. So at index 0, we have a sum which is 8, so our required is 8 minus 5, which is a 3. So we are looking for something like a 3. We are going to check on the map. We'll query the map that have you seen a 3, but unfortunately at this point of time our map is empty, so we are going to get a 0. So count remains at 0. 0 plus 0 is a 0. And what we are going to do is we are going to update the map and tell him that I have seen 8 one times, right? Because we saw this sum one time, which is a 8, right? Moving on to the next index, we have a 6, so our sum becomes 14. Now, to get a 5 from 14, what we need is a 14 minus 5, that is a 9. So I'm going to ask my map that have you seen a 9 somewhere? So there is no 9 in the map, so it's going to return a 0, and will continue to remain at 0. Okay, and what we'll do at the same time is to update the map saying that I have seen 14 one time. So this is the very important part, and also to maintain the count of the same, right? So now I get a minus 14, and what happens is my sum becomes 0, right? And with that, what happens is I go and check my required. So what I need at this point of time is, if I have seen a minus 5 somewhere, then I can say that, yeah, I can make a sum of 5 with this subarray. But what we see on the map is that there is no minus 5 over here, right, in the present in the map. So the map is going to return me a 0, and we will continue to remain at 0. So we are going to update the map saying that we have seen 0 one time, right? Now to move on, we get a value of 3, so our sum becomes 3, right? And to get a 5, what we need is a minus 2 at this moment. But when we check the map, there is no minus 2, so I'll get a 0 from this map, and our count will remain at 0 only. And at the same time, I'm going to say that I have seen 3 one time, right? So moving on, I get a 2, and what happens is I get a sum of 5 now. And before we do the required and all, what we see is that this condition has been satisfied. We see that sum is equals to k. So we are going to do a count plus plus. So count was at 0, and we are doing a plus plus, and it takes me to 1, right? Then I'll go to the required part, and I need a 0 in order to say that I can make another subarray, right? So so this time my maps tells me that, yeah, I have a 0, right? So he's going to send me back a 1, unlike the previous cases, and my sum goes to, and my count goes to 2. So now if you look over here, so this is the first sum that we found, right? Actually, no, this is not the first sum we found. We were maintaining a running sum, so we found this sum. Sum has given me this result, and I know at this index it is 0, and at this index the sum is 5. So I know that this difference is nothing but a 5, right? So that's what my map has returned me, and I have updated based on that. So my count has moved to 2 at just a single jump, right? So you can see that how this map is helping us to build the result and to come up with the right values, right? So the next index is 5, and we get a value of 6. So our sum becomes 11 in this case, and 11 minus 5 is what we are looking for. So 11 minus 5 is a 6, and I don't see a 6 on my map. So I continue to remain at 2, right? And at the same time, I'm going to tell my map that I have seen 11 one time. Moving on, I get a minus 1, so my sum comes back to 10, And 10 minus 5 is a 5. We need to see that we have seen any 5 or not anywhere, but my maths tells me that there is no 5, so we are going to stick to 2, and we are going to update this map with the value of 10, which has been seen one time. So now let's consider, just to understand. So you get this part, right? That we are going to end up having two matches. So now, had this been minus 5 instead of a minus 3, so let's update this value to a minus 5. So we can see that another case will be matched over here. Okay. So what we get is a minus 5 over here instead of a minus 3. So let's strike this off and put a minus 5. I just wanted to build this example. So we do a 10 minus 5, right? And we get a 5 over here. So what happens is we again hit this condition right over here. So what we are going to do is we are going to update this to a 3. Had this been a minus 5, definitely. So our required value becomes sum minus k. So 5 minus 5, that is a 0. So we are going to ask the map that have you seen a 0, and it tells me that it has seen a 0. So we are going to do a 3 plus 1, and we are going to say that we have 4 such subarrays, right? So now let's understand where are those results, where are the third and fourth result. The first and second we have identified in these two places, right? So definitely the third one stands at the entire array, which is a 5, right? The total is a 5. So if I have to update this, so let me put this, so it will also be updated because we have changed from minus 3 to minus 5. So this is our third match, right? And there is a fourth match as well. So let's understand where the fourth match is. Now if you see, just notice over here, this 3 over here, 3 plus 2 is 5, right? And what we have is a minus 6 over here and a 6 over here, right? So this subarray over here has contributed to my fourth match. So this 3 plus 2 is a 5, right? And if you add all the remaining things, you will get a 0, right? Minus 6 and plus 6 is a 0. And so this is your fourth match. So this is the algorithm all about, right? Where we are maintaining the sum of every subarray at all the steps. So let's move over to the Leetcode and let's get this solved in Leetcode. So the solution is going to be very straightforward. We are going to do exactly the same thing as we have discussed on the board. So we are going to have a map and we are going to call that a scene map, and it's a hash map implementation of integer and integer, and also a bunch of variables that we have talked about. So one is a sum that we are going to maintain and the other one is a count, right? And this count will have the list of subarrays or the count of subarrays at the end of the loop, right? And we are going to go over this nums array and we are going to do a continuous sum, right? So sum plus equals to n, we are continuously going to do it. And if any point we see that sum is equals to k, right, then what we are going to do is we are just going to do a count plus plus, right? And we are going to also keep a track of the required. So let's declare this required over here, and required is nothing but sum minus k, right? And we are going to do a count plus equals to, we are going to use a get or default because it might happen that the key itself is not present. That's how we are going to update. So 0 plus 0 will eventually become a 0 only. And otherwise what we are going to do is we are going to update the scene map and we are going to put the sum. And again, we don't know that sum is there already inside this map or not. So we are going to do a get default with scene, and we're going to say if this key is not there, give me a 0 so that I can increment and put a value 1, right? So yeah, this is the entire algorithm all about. There is nothing much to it than this. So let's run this code and check. Keeping my fingers crossed, it should run. Oh, too bad. So what did I screw up over here? So I have written sum, it should be seen. I have to get from the map, right? So my bad. I have reversed it, put the sum there, seen here, sum there. Anyways, let's run and check. Looks good. Let's do a submit and check for a wider range of test cases. I hope it runs. Yes, it did. And yeah, we are better than almost 40% of the submission. So I hope you got the solution that we have discussed with both the test cases, and you have got the clarity on how we are doing things and how at every step we are maintaining the subarray sum and also maintaining a count and what is the rationale behind the same, right? So yeah, before we end the video, let's quickly understand the complexity part of it and then conclude the video. So what what we are doing over here, we are creating a map, right? And what is this map going to hold? This map is going to hold the sum, right? And how many sum we can end up having in the worst case? In the worst case, we can have n mapping stored over here, right? Like all the sums are unique and we end up storing n mapping over here, where n is nothing but your length of the array nums, right? So count and sum, these are your constant space. This required is also your constant space. And yeah, that overall, this is your space complexity over here. So for space, you will have an order of n. And also for the runtime, if you see that we are iterating once over this entire array, right? So runtime complexity will also remain at order of n. So this is going to be a pretty much linear solution for you, both in terms of space and runtime, right? So do let me know what you think about this solution. Do give a like if you think this video was helpful, and if you think I have some areas to improve on the video, some areas where I was not able to explain properly or I should go in details, don't hesitate, let me know. I will try to improve myself. And so yeah, if you want me to solve any particular problem from Leetcode, do let me know, or from any other platform or any concept or any offline problems as well, do let me know. As I always mention, though it's a good thing that I have started hearing from you guys, and it's also good to see that the channel is growing. We are nearing almost 200 subscribers, just 4 or 5 short of them. I hope by the time I make the next video we should be there. So yeah, that's all from this video. Hope to see you guys soon again. Bye bye, take care.